Hello, ladies and gentlemen. Today we are going to take a look at some of your favorite things, story problems. Yay! So for our notes today, we're going to need that little foldable that you have that space. I think it's the last page in there, so make sure you find that. Something to write with, and yes, a calculator because some of the numbers we're about to get are not ones you're probably familiar with when you multiply or add or subtract. They occur in real life, so lots of dollars and cents, if you will, that we'll be adding and subtracting today. So we're doing story problems, and I know you're thinking, why do we have to do this? Well, just remember that overall we have all these goals and all these standards we need to accomplish, and only one of them says you need to solve exactly and approximately. There's a whole other standard that says you need to be able to create the equations. So basically, given a story problem, you need to be able to create the equations that would match with that story problem, and then, of course, be able to solve them using elimination or graphing or whatever you want to do. Okay? So remember, we're working towards these goals. This is your foldable. You need to find that last page, the story problems page. We're going to do two story problems in your notes. That's it. So maybe one on the top half and one on the bottom half. And we're going to show all the work. And yes, you need to write the story problem down. Okay? So this is the first story problem. I need you to pause the video to write this down. And then I will read it to you and we'll start to solve it. Okay? I said pause it. Did you pause it? I hope you paused it. Okay, you should have paused and written the whole problem down. It does no good for you later if you don't have an example of the word problem as well as the equations, okay? So let's see what we got going on here. It says you and some friends decide to go see a movie. Luckily, your friend has a gift card to use on the concessions at Grand Theater. The concession signs are down, but the person working tells you that you can buy 2 popcorns and 2 drinks for $18. Or you can buy 1 popcorn and 3 drinks for $16.50. How much does each item cost? So basically we have this situation where we need to define what it is that we're looking for so we even know what variables we're going to use here. So sometimes when I attack story problems like this, you'll see me do a few strategies. They're reading strategies really, but they help you solve a story problem. So in this story problem, I'm going to underline all the numbers. 2, 2, 18, 1, 3, 1650. All of these numbers are going to be important to us mathematically. I also am going to take the time to circle the question here. How much does each item cost? So what is it that we're looking for? We're looking for the cost of each item. Well, what about each? What is each? What 2 items are we talking about here, or 3 items? Well, in this case, we're only talking about 2 items. We're talking about buying popcorn and drinks. So we first want to define what it is that our x and y are going to stand for. So in my equations, x is going to stand for the cost of, how much does each item cost? What item should we use? Popcorn or drinks? Let's just go popcorn. So x is going, ooh, corn, hello. X is going to be the cost of popcorn. And y will then be the cost of the drinks. So what we're talking about here is setting up equations that will help us solve for this. Let's go ahead and read back through those underlined parts here. The person working tells you you can buy 2 popcorns and 2 drinks for $18. So if I was going to turn that sentence, just this one, 2 popcorns, 2 drinks, $18, into an equation, it might look something like this. 2 times the cost of the popcorn plus 2 times the cost of a drink will add up and make $18. There's one equation we know is a true fact based on our story problem. But there's another one. I've used this, and used this. What about back through the next sentence here? I can buy 1 popcorn and 3 drinks for $16.50. So that might look like 1x plus 3y equals $16.50. Once I have the equation set up, then all I need to do is be able to solve using elimination, using graphing method, using substitution, whatever you want to do, but elimination's the most recent in our head here, so let's stick with that. I see I have a 2x up here. What would I want beneath that in order to cancel with that 2x? I'd want a negative 2, right? Well, right now I don't have that, but if I multiply this one by negative 2, I can. So the top one I'm going to keep the same. Oops, equals 18. That's an equal sign. And then negative 2x minus 6y equals, and now here's where your calculator comes in, 1650 times negative 2 is negative 33. Now if I add those two together, I don't have any x's, but I have negative 4y, and then negative 33 plus 18, make sure that you have a negative answer, that's negative 15. Now if I divide by negative 4, divide by negative 4, y equals, I should get $3.75. All right, now it's okay to get a decimal here because we're looking for a cost of something. So the cost per soda or per drink is $3.75. Now how can I go in and get the cost of the popcorn? Well, let's go back then and plug it into one of these, like maybe the second one, I don't know. The second one right here says 1x plus 3 times the y, which was 375, equals 1650. So 3 times 375, guys, is 1125. So we'd have 1x plus 1125 equals 1650. We'll take 1650 then and subtract the 1125 from it to get the x alone. And we get x to be 525. So what did we just find out? We just found out that it costs $5.25 for popcorn. So I'm going to write that for popcorn. Adding a label is very important. And $3.75 for a drink at the theater. Okay? So story problems, we're going to read them, we're going to set up our equations, and we're going to solve using the elimination method or substitution, whichever you prefer. All right, let's try another one. The Hamilton family is going on a Florida vacation. The cost for a day at an amusement park is $550, and the cost for a day on a family cruise is $800. The whole budget, the total budget for the Hamilton family is $4,600 for 7 days. How many days should they spend at each place? So again, take some time, pause this video right now so that you can write that whole story problem into your notes. For real, not kidding. Make sure you pause. Did you pause? I'll wait again. Okay, now I believe you. You paused. All right, and you wrote that whole story problem down. So we're talking about a family going on vacation. There's lots of numbers in here. Let's first get those. $550, $800, $4,600, and 7 days. I'm going to also take a look at how many days should be spent at each place. That's the big question. So we have numbers in our story problem, and we also have how many days is what we're looking for, the question of the story problem. The whole focus of our answer is going to be to figure out how many days we should be spending at each place to stay within our budget. So let's define our variables. We're going to have an x and a y. How many days should we spend at each place? Each place, what does that mean? Oh, well, they're going to either an amusement park or they're going on a cruise. So I'm going to define my x and my y based on how many days, because that's what the question's asking, they should spend at each place. So my x is going to be days at the amusement park, and my y is going to be days on the cruise. Okay? So now let's take a look. Once we've defined, we're talking about days here. X and Y are going to be in days, so not a cost like the last one. Let's take a look at some of the numbers. It costs $550 for an amusement park day and $800 for a family cruise day. So we might write something like this. $550 for an amusement park day, that was X, right? Plus $800 for a family cruise day, that was the y, equals, now notice that these were all dollars and dollars. Well, how many dollars did we have to spend total? $4,600. We don't have any more than that, so we've used now all of these numbers in setting up that first equation. But we still have this 7 left over here. Well, keep in mind that x is the number of days at the amusement park and y is the number of days on a cruise. So if we just added the days at the amusement park plus the days at the cruise, it has to equal 7. They have 7 days of vacation. So these are our two equations. We've used all the numerical values now, and now we're going to solve to find out how many days we should spend at each place. So we're going to again use the elimination method. I'm looking up here, I have $550 in front of each x. Underneath that, I'd like negative 550. So negative 550 is what I'm going to multiply by. So the top one's going to stay the same, 550x plus 800y equals 4,600, and the other one's going to become negative 550x minus 550y, and then 550 times 7, oh, remember that's a negative, is negative 3,800, oops, negative 3,850. So now let's add those guys up. These x's will eliminate. We'd have 800 minus 550, which is 250 y's. And then we have 4,600 minus 3,850, and we end up with 750. So if I divide by 250 now, divide by 250, we get y equals, how much, ladies and gentlemen? 3, right? Y equals 3. So I'm going to place that as one of my answers now into one of these original equations that I started with. It looks like this bottom one looks pretty easy. Y plus 3, or x plus 3 equals 7, sorry. Because the y is 3, I now know that the x is 4. They had 7 total days of vacation. They're spending 3 and 4 at each place. So remember, x equals 4 for what? What are we talking about? 4 days at the park. And y equals 3 days on the cruise. Okay? So setting up story problems from, taking equations from story problems, it does take a little bit of practice, but I encourage you to use those reading strategies of underlining and circling important key information in there that you can then translate to the math equations. Once you have the equations, I know you know how to solve. All right, I want to thank you for taking good notes, ladies and gentlemen, and I'll see you later. Kincaid out.